Bismillah ar-Rahman ar-Rahim. Let's continue talking about the ERD to finish the discussion and then have some exercise. Last time we talked about the multiplicity. We finished our talk about the multiplicity. What did we say? Say that we have two important numbers, cardinality and participation. Cardinality is the maximum limit and participation is the minimum or the lower limit, right? Let's have some examples to explain. We also knew before that the relationship type is one-to-one, one-to-many, many-to-many. So let's have some examples to mix both together, to see examples of having one-to-one, how it relates to the multiplicity. Here is an example, and in this example we have what? Staff managed branch. Staff managed branch. Look at the participation and the cardinality, the multiplicity, the numbers. We say, let us try to read it more carefully or more closely. Each staff, let's read this direction. Each staff may manage, why may? Because we have a zero here. So may manage, which means that not every staff is a manager. Not every staff is a manager. So may manage a branch, one single branch. So if not every staff is a manager, and if he is a manager, then he will manage only one branch. The other direction says what? The branch, or each branch, is managed by how many? By one and only one. Each branch must be managed by one single manager, right? Now let us see how the occurrence diagram, or sometimes they call it the semantic net, works. So we have here a set of staff persons. We have here a set of staff and two branches. Now, is every staff a manager?
No.
So now let's try to read it again. So each staff may manage. So SG37 does not manage. Not every staff manages. So SG33 is not a manager. However, the other two are managers. When they manage only one branch. So the staff will not be linked to more than one branch, right? The other way around says that every branch must be managed by one branch, one staff. So everyone having one link coming out of it to a manager, a staff member, right? So this is how to represent it in occurrence diagram. Clear? Let's have another. This relationship is what? What is the type? One-to-one, one-to-many, many-to-many. One-to-one. Why? Because you see that every link, we don't have two links coming out of any node of these, of any occurrences. Neither this side nor that side. When there is a link, there is only one link coming out of this node, right? So this branch has only one link coming out, and this one coming has only one coming out. This is from the occurrence diagram. How can I tell from looking at the ERD itself? We take the cardinality, the one here. So this is one, and this is one. So the relationship type is 1 to 1. Okay? Let's have another example. Here, the relationship between staff and property for rent. So we say that staff oversees property for rent. Oversees means manage, look for. He is the one, look after, sorry. Look after. He is the one who takes care of, and so on. Okay? So the staff oversees property for rent. As staff oversees property for rent. Now, let us look at the multiplicity here. This says what? That each staff oversees every more than one property. Yes, it oversees more than one property. However, not every staff can oversee properties, right? Some staff are accountants, some staff are managers, and so on. So not every person is taking care of a property. So here is a 0. So if these are the staff members, not every staff is managing, is controlling or is overseeing a property, right? This one is SG5 is taking the 0. It's taking this 0. It's not managing anything. It's not overseeing anything, right? However, SG37, for example, is overseeing what? Many. Overseeing many. One is also possible. When we say many, means one or more. So this one is overseeing one property. This one is overseeing many properties. This one is overseeing nothing. It's taking the 0. Okay? Now from the other way around. Every property, or each property, is overseen by one staff, not more than one staff. But not all properties are overseen. Some of them are not assigned yet to somebody. Maybe in the transition period, we did not assign it to somebody. Or maybe the one who was working for it is resigned, left the company. Okay? So at that point, there is no one is managing it. It's not overseeing it. So back to the diagram. Some of the properties, PG4 for example, is not overseen. It's taking the 0. While if it is overseen, then it is overseen by a single staff. No more than one link coming out of any of these properties. Right? So that's how to represent these types of participation. Consider these two zeros. Now for the type. 1 to many. Is 1 to many. Why 1 to many? Because the cardinality is 1 to many. One last example for many to many. Let's assume that we have newspapers, and in newspapers we advertise for our properties for rent, and every property could be advertised in many newspapers. So the relationship in this newspaper is used to advertise property for rent. Now, is it for every newspaper? Each newspaper has one ad, or maybe having many ads for the same property. Each newspaper may have advertises, right? For one property or for many properties? For many properties. Maybe many properties, right? Maybe one. Is it possible that I have in my database a magazine or a newspaper that we didn't use for advertising? Why, if this is the case, why should I store something about it? It's for me, it is not used, right? So I'm saying I'm not going to store any data about newspapers in my database unless there is an advertisement. We have used it for advertising, at least for one property for it. So that's why 1 to many is used here. It means that each newspaper must have. One here means must have at least one property for rent. This is represented here like this. A newspaper must have at least, none of these newspapers is not linked, because it must have one, at least one. So some of them having one, some of them having more than one, but none is not linked, right? The other way around, a property for rent, each property for rent may be advertised, because there is a zero here, may be advertised in a newspaper, right? In one newspaper, no, I can advertise it in this newspaper and that newspaper and so on. So it may be advertised in one or more newspapers, right? This is how to read it moving this side. So these properties for rent, for example, are advertised in these newspapers. So PG21 is advertised in one newspaper, while PG36 is advertised in two newspapers, right? One of them is not advertised at all, PG4, because not everyone is advertised. Questions? Okay, good. Let me go to describe another representation. We use this notation. We use this notation here to represent the multiplicity, right? There is another representation. There are many other representations. In fact, this representation is used or start being used when the UML notation is developed. When it is designed or developed, we start using this notation. But before this, we were using another notation. It's very important to know. This notation is called Crowlfoot notation. Crowl is like the crowl, the chicken foot. Anyway, here is the multiplicity that we used to see, and here is how it is, or it was, represented using the Crowlfoot notation. Okay? So if it's 0 or 1, what I do is I write 1 here and 0. Let me explain it. I'm assuming that there is a box here and there is a box coming here, right? So we are talking about this side. So there is a box here, for example, department or branch. So instead of using 0 to 1, I use, this is the 1 and this is the 0. Got it? Let me write it here. If we have something like this, instead of writing 0 to 1, I write it this way. This is called the Crowlfoot notation. And you may be asked in the exam, give it in the Crowlfoot notation. Or I give you a diagram, an ERD diagram, using Crowlfoot notation. So you have to be able to read it. Huh? So 0 or 1, or 0 to 1. Okay? If it is 1 to 1, then it's just 1. Huh? We don't have to mention the 0 or draw the 0. It is 0 to many. The many is this. This is the many. The three, the crowl, huh? This is the crowl. So it is either 0 or 1, right? Like this. We don't have representations for other notations, for other multiplicities like these. So if I have from 5 to 10, 5 is the what? Participation, and 10 is the cardinality, which means that I have the minimum of 5 and a maximum of 10. And we gave examples for this. If we said that our sections here in the college are having a minimum of 5 students and a maximum of 30 students. Okay, they don't open a section unless there is at least five students, for example. Okay, of course, this section is exception. So it's we write it. How can we write it? 5, 2 points, 30, which means that from 5 to 30. Minimum 5, maximum 30. So we don't have representation. You have to write it this way. Also, if you have something discrete points like this. Okay, by this is not the only notation in the PowerPoint you have. We have different other notations you can review. As we said, let me remind you, these are many dialects. Let me remind you, we said that the language, ERD, is a language. And a language may have many dialects. لغة ولهجات. مش كده؟ Many dialects. So we have many dialects. The most commonly used are the two we have discussed. Or actually, the three we have discussed. What are the three? The normal notation, which is this, in which we use the attributes like this. This is single, simple, single valued. This is multi-valued attribute, right? This is composite attribute. Remember? مش واخد بالك ولا ايه؟ This is the attribute, and these are the composition. This is multi-valued, double-edged attribute, right? This is a key. There is an underline. This is a simple attribute, right? This is a relationship, right? and so on. This is the entity, and so on.
What's the double diamond?
Double diamond and the double-edged box are for weak entities. We did not discuss weak entities. Okay. A weak entity is an entity that does not stand for itself. Let me show you an example. The dependence. Let's go back to the beginning. Dependent. A dependent. In discussing this point, we said that their dependent represents the children and the wife of an employee. Those اللي هو يعتبر ولي الأمر بتاعهم يعني مش كده؟ So those are the dependents. So the question is, should I have in my database those dependents if I don't have their parent, the employee himself? If the employee left the company, what should we do with these dependents in our database? Should I keep them in the database? Of course not. Why did we store them in the database at the first place? For example, because they gave them some insurance, medical insurance or something like that. So if as part of our contract with our employees, we gave them medical insurance. They and their family. Okay? So we need to store the family members. Huh? But we store them because of the employee himself is working with us. If he is not working with us, then those have meaningless. Right? So the existence of those dependents in my database is dependent, is weak, needs somebody else to support it, exists only for this support. So we call the dependent a weak entity and the employee a strong entity. So we relate them together. If this is a dependent and this is an employee, this is the dependent. The dependent here should be of double edge to express it, to mean it is weak entity. But if you don't, we accept that as well. If you don't represent double edge, we accept that. Many ERDs don't think of the weak entity, because at the end it's a table in all cases when converted to a logical database. But the actual situation is that it is a double edged. Let me show you how it is represented in another diagram. Yes, here is the dependent, is a weak entity. What is the strong entity related to it? This is the relationship. So the employee or the dependent is a dependent of this employee, or the employee has those dependents. So this dependent is a weak entity, and this is the strong entity. So we represent the weak entity as double-edged, and we represent the relationship like this.
What is the 0 to n in supervisor?
It is the 0 to 1.
1.
This is the multiplicity. This notation in this book, Masri, represented this way. I didn't like to mention it, but it is in the Masri book. That does not use the 2 points. It uses this notation. And it uses, by the way, the diamond for all types of relations, 1 to 1, 1 to many, whatever the relation is. He doesn't use the line. He uses always the diamond. But this is not good for us, because we, as I said, let us fix, or let us agree together that there is a convention that we are going to follow. We use the diamond only for one of 3 reasons, or the 3 together. Again, let us remind ourselves.
Has multi.
The degree is higher degree. We have many, more than 2. This is the original reason. We have more than 2 entity types related together. So higher degree, more than 2.
And has attributes.
Has the relationship itself has attributes, and the third, many to many. If it is a many to many relationship, we prefer it to be like a diamond. A line is good, it's not wrong, but it's not preferred. We prefer it to be a diamond. Why? We'll know that in next week or something. Okay, so we have many representations. We discussed the UML representation, in which what? The name and the attributes. We don't care about the methods. This third part here is for the methods. We don't care about it in the database, in the relation database at least. And we have the multiplicity is represented like this. They don't, by the way, in the pure UML, they don't use the diamond. So the relationship here carries this. But this is not our concern here. We have a mix of many notations together. So we have many notations. That's what I wanted to tell. So use the notations I taught in the class. Okay. Either the difference is in the attributes. Either the attributes are used as ovals, or they are written in the box down the title of the entity type. Down there are the attributes, and we knew, or we discussed how to represent the different types of attributes. If it is a key, then you write besides it primary key, or underlined is also accepted. If it is composite, you just indent the composition. If it is derived, use a slash, backslash, derived attribute, and so on. So if this is the multi-valued, you use the braces, right? Okay, so we already know how to represent or use the different notations. Now let's have some exercises. Ready? some exercises to get more practice. Assume that by meeting or interviewing our user, this is what we have obtained. This we expressed our understanding in terms of words like this, or this is what he exactly says. Okay, so let us take it part by part and try to draw the corresponding ERD. Here, I want you to share. Who volunteers؟ يلا ساعة واحد يطلع. هنحل سوا. Let's start reading. The idea is we need to identify the entity types, their attributes and relationships and multiplicity. That's all we need to identify or to draw an ERD, all the components of an ERD. So we said, again, back to our discussion, we said what? We said the entity types are nouns.
Yes.
So nouns here are either entity types or their attributes. How can we differentiate? Of course, an attribute describes an entity type. So this would be clear from the discussion. Again, is every noun be an entity type? No, we said let us look at the scope of the mini word. What is the mini word? If something inside the scope, then it is an entity type. Outside the scope, it is not an entity type. The relationships are the verbs, right? The relationships are the verbs. And of course, numbers will be treated as the multiplicity. Out of that, we are going to extract or know the multiplicity. Now let's start reading. Assume that at Pine Valley Furniture, this is the name of a company, Pine Valley Furniture. So this is a noun.
It's outside the scope.
It's outside the scope because it is the company itself that owns the database. Each product, start talking about another noun, product, each product. Between brackets it says described by, so that product is described by. So these are something that's describing the product. So if there is a noun that we need to store data about it, we need to store properties about it, then it's most likely an entity type. Also, if there are many of it, how to tell this is an entity type. So I give you few clues, okay? One is that it has properties describing it, okay? Two, there are many occurrences we need to store. Students, we have Muhammad, Ahmed, and so on. So we have many students. Here in our example, product. And it says each product means that there are many products. So there is indication that, yes, we need to store many products. So this is most likely to be an entity type. And the attributes are clearly described between brackets. Product number, description, and cost. So at least at that point, I have identified a product. So I can draw a rectangle representing. لا يعني تعالى فوق كده على الشمال خالص. يعني مش لا جوه يعني هنا between. لا مش لازم قوي كده يعني مثلا هنا كده. خلي دول. لا
تبغى انت حطيتهم؟
دول بيحددوا بس فين بداية الصفحة عشان تبقى باينة في الصورة اللي بتاعتنا. طيب okay, let's start. But leave a space for the attributes. Okay. What's the name? Product. Very good. Did we identify some of its attributes?
Yes.
Yeah.
The number.
Product number, description, and cost. Of course, you can use acronym, simplify the word. Number is enough. P number P number is better. P number. P number. Okay. Description.
Description.
Another attribute. Description. DESR is enough. We usually use the abbreviation DESR as description. And unit of measure. Write it unit. Unit is, I'm sorry, the cost. Cost, okay. Let us keep reading. Product, let us forget what's in between brackets. Each product is comprised of at least 3 components. This is an English sentence. That's a correct English sentence, right? 2 nouns, right? And a verb. Each product, this is the first noun. Component is the second noun. There is a verb linking it together. Is comprised of. Let's forget at least for now. These 3, let's forget for now. Now we have what?
Relationship of comprise.
Yeah. It indicates that there is another noun, component, and to simplify our life, the user placed in between brackets some of the characteristics, some of the properties of the product. So let me draw the component. What حوالي؟ ها؟ ليه مش واضحة؟ Component between brackets described by component number, description, and unit of measure. So again, component 1 يعني okay. What are the attributes between brackets? Component numbers, component number, C number, okay. Description and unit of measure. Unit is enough. هنا مشكلة الرسم انك ضيقتها قوي. طيب anyway. Now let us read the full sentence. The meaningful sentence. Remove from the sentence all words that doesn't matter. I need to focus on the 2 nouns and the verb. So let us reread the sentence. Each product, forget what's between brackets. Each product is comprised of, this is a verb. Right? Let us forget at least 3. Is comprised of components. Each product is comprised of components. Is that a valid sentence? Meaningful sentence? Yes. So we have 2 nouns and a verb. So there is what? Relationship. Just draw the relationship. Comprised of. Composed of. Made of.
Make it a diamond.
We use the diamond for a specific purpose. So let us for now draw it as a line, and later on if we discover that we need it as a diamond for one of the 3 reasons, we will draw the diamond. Okay? So what's the name? Give it a title. The label.
Comprise.
Is comprised of. Now write full sentence. Is comprised of. ED. This is the label of the relationship. It is one word. You write it as one word, as we used to name the variables in Java, for example. So the C in the comprise will be capital letter. The O will be another capital letter, just to make make it readable. Huh? one word representing the whole phrase. واضح يا سعد؟ هنا في التسمية.
هذه
Yeah. This should be named one single variable. One single variable. One single name. Exactly like you do in Java, for example. So then you use what? Make the C as capital. Don't leave spaces, of course. And the O of as capital.
about the I.
Yeah, exactly. So the products are comprised of, or product is comprised of components.
So here should not be.
No spaces. Okay, up till that point, that's all the information we know, right? Let's continue reading. And the components, he's talking now about the components, are used to make one or many products. Okay, he's talking about, now let us go back to this relationship and see the multiplies. We have removed at least 3, right? We don't think of it yet. So let us now rethink it. Products is a product is comprised of how many?
3 components.
At least 3. What does it mean at least? 0 is possible? No. From 1 to at least 3. From 3 to more. So the minimum is 3. Where to write it, Saad? Keep reading the sentence. Product is comprised of, write the number, then components. So that the sentence is readed.
At least 3.
Where to write it? No. Think. Read the sentence. Yes, exactly. The sentence should be on the read exactly the same way as in the text. So the product, read the sentence as you write it here. Product is comprised of, and then write the number before reading the component. 3 to much. When it says at least, it means
There is many.
many. From 3 to many, right? Exactly, from 3 to many. Now it says it reads the same sentence, the same relationship from the other way around. It says, and the components, talking about components now, are used to make the other direction here. Listen. One or many products. He's talking about the other direction. So components are used to make, this is the opposite direction of, is comprised of.
One or many.
One or many. How to represent one or many. So read the sentence the other direction. Components
Components.
are used to make, don't write it.
Okay.
One, two,
To what?
used to at least
Make one or many.
one or many.
So one.
Look at this, Abdullah. If you write it this way, where is the minimum? Where is the maximum? Yeah, the minimum is always to the right, to the left. Exactly. Must be used in at least one product. This is just an explanation. This in between brackets is just an explanation. It stresses that there must be a one. Now this sentence is finished, but look at your diagram before we continue. Look at your diagram. The relationship here is which type?
Many to many.
Many to many.
Cardinality.
You can leave it like this. Yes, the cardinality, you are right. You can leave it like this. It's correct, it's not bad, it's not wrong, okay? But we said that let us follow a specific convention that we are, for us. What is the convention? Many to many is represented as a diamond. We said the diamond has 3 reasons. We just mentioned the 3 reasons. One of them is
Many to many relationship.
so replace the line to a many to many relationship. You just do like this. We just use it like this. That's it. The same title is comprised of. You keep it's comprised of. Okay, let's keep reading. The model is not finished yet. In addition, assume that components, he's talking about components now, are used to make is a verb.
Yes.
Is a verb. Other components. Components are used to make other components. Noun and noun with a verb in between. Used to make or makes.
Okay.
Huh? So components make
Recursive.
recursive. Excellent. Draw it. Yes, it's correct, but we prefer it to be to start from here,
Okay.
from one side to the other side.
This side or
يعني هنا طلع من السايد ده دخل على سايد يعني
Okay.
مش جاي من نفس السايد.
Fine.
Okay.
This is the mean.
The verb here
Used to make.
makes. Used to is just makes or make. In fact, we usually name it in plural. Products, components. Anyway, keep it like that. In addition, assume that components are used to make other components. So that's recursive. And that raw material, look at this. Raw material. That raw materials are also comprised of where we are. And that raw materials are also considered to be components. So the components, the occurrences in the components, inside the components, if you open the components, you will find many occurrences. Right?
Okay.
C1, C2, C3, and so on. Some of them are making other components. Or some of them are made by some other components. That's recursive. Itself is made by other components, right? While some of them are raw material. Raw material is what do we mean by raw material? Raw material is kham. It's not made of anything, right? Right? Okay. طيب. This word, this sentence here, does it carry the multiplicity? The sentence finished now, right? Considered to be components. It's finished. Where is the multiplicity? How can I tell the multiplicity? Let us read again. Components are used to make other components. A component is used to make other components. Many or one? Or what?
Many.
Yani a component from this side. A component each, we are going to, exactly as we did here. We move the trip both directions. So let us start from here. A component here is made exactly like we did for the prerequisite. Remember the prerequisite for courses?
Yes.
So a component is used to make or makes many components. So here I write many. Each component is part of many components. Right? Huh?
So it's many to many.
Many. You write here. Here is the line. Here is the line.
Just many.
Many. Right? But we will think of the minimum later on. Let's assume 2 components here. Exactly as we did with 2 courses. Okay, let me explain it in terms of courses. This is simpler for you to understand. Let's assume that we have here a course. Right? And there is the prerequisite relationship. right? So let us assume that we have a course here. So a course here and a course here. This link is linking two things together, right? So one course here, each course here is linked to how many here? Is used as a prerequisite for how many here? 240. 204. 204 is a prerequisite for what? For 240, right? And for maybe some others, right? So it may be linked to many, right?
Right.
Right? Now 240. We said 204 is a prerequisite for 240. And 240 has how many prerequisites?
One.
Maybe one, maybe many, right? So in that direction, the same course here may have many prerequisites, right? So it is here many. You got it?
Yes, got it.
واضحة؟ يعني this one is a prerequisite for this, but it may be many, and any one of those may be having a prerequisite or many prerequisites, right? So let's talk about the participation. The participation, the minimum. Huh? The minimum. One means that all courses must have a prerequisite.
No.
Huh? How about the first, the beginning? At the beginning, or for beginners, there is no prerequisite, right? So some of these courses have no prerequisites. How about the other direction? Is this course a prerequisite for somebody else? The 400, for example, are not prerequisites, right?
Right.
So it is
Zero.
0 here. So remember recursion, when you studied recursion in 204, the code? They said there is what? There must be what? A termination condition,
Yes.
right? There must be a termination condition. So the termination condition, if you don't have a 0 here, then you keep,
Infinity.
it keeps
Infinite
recursive. So you usually or always, for recursion, the minimum must be 0. The maximum, the cardinality may be many or whatever. Okay, so back to our case. The raw material is the 0. By the way, raw material is like the case in courses here. It is the beginner, the base case. It is the base case. The beginner. Right? So back here, so there must be a 0. Even if he didn't mention the raw material, there is no way, but we have to use the 0, otherwise you will not terminate. Now the component is made of many components, and the component is part of or is used to make how many components? Many components, as he said. Exactly. Now again, this recursive relationship is of which type?
Many to many.
Many to many. So it's better to use the diamond. Exactly. Yeah, of course, it's better to have the line go to the edges, to the corners. Very good. Did we finish? In both cases of components, once being of components, something حد داس على حاجة هنا. In both cases of components being used to make up products, this relationship, components used to make products, this relationship, and products in both cases of components being used to make products and components being used to make other components. He's talking about the two relationships. مش كده؟ This خليني طب اقعد هنا واقراها لك عشان بس نشاور بالماوس. بنقول هنا ايه؟ In both cases of components being used to make products. Components being used to make products. In both cases of components being used to make products and the components being used to make other components, the recursive. Components being used to make other components, the recursive. He's talking about the two relations. In both relations, what happens? We need to keep track. Keep track means stores. We need to keep track. We need to store. To save data. To keep track of what? How many components go into making something else? How many components are the numbers? When you say the product is made of components, how many? When you say this, for example, car product, has or comprised or made of طبعا many things, among them wheels, engine, door, body, and so on. مش كده؟ طب now how about how many? Let me draw it like this. This is a car, right? It's linked to here the components, right? Wheels, engine, chassis or body, right? And others. So this is many, or at least three, right? Now, how many wheels? This is wheels. How many wheels? That's the point. We need to keep track of how many wheels. That's what the sentence says. So we need to write here four wheels. Right? And here we need to write, for example, if it is an engine, we need to say one engine, and so on. So this we need to keep track of. When you link a component to a product to a component, how many of these components? You got the point?
Yes.
So how to express this?
It's an attribute of the relationship.
Exactly, it's an attribute to the relationship. So you write it here as something like this quantity.
No, it makes components.
Yes, products comprised of or components makes products, or products comprised of it is the same relationship. If you read it this other direction, so here is the quantity. How many? Same for this other relationship. You got it? Yeah, that's what you have done. Okay, this is the way of how to read the description that a user just told us, and how to express it in terms of an ERD. Please think of the other two examples, and we'll take half of the next lecture to work on them. Okay?
Okay.
If you don't think of them, we will go into the next topic directly. Okay? Let me spend these 5 minutes in at least to explain them. A software training program. Software تقرا معايا وين صور مش همسح حاجة. A software training program is divided into training modules. So there is a verb here, is divided into. And we have training program and training module. So it's clear, two entities, training program, training module, or call it program and module, and there is a relationship is divided into. Now there is some multiplicity hidden here, I leave it for you. And each module is described by module name and approximate practice time. So these are attributes of the module. Each module is described by, so right? Are these types, entity types, or attributes? Attributes. They are describing, right, the module. Each module sometimes have or has prerequisite modules. Exactly the course here. A module has a prerequisite module. He's talking about training. So he has courses, program and program, IS program, for example. IS department program is composed of, is divided into many modules, many courses. And each course, each module is described this way, by these attributes. And each module sometimes has pre-modules. So there is a recursive relationship. It's something like the same diagram as above, as here. Huh? Now there are multiplicities hidden in these sentences. I leave it for you. Okay? But here is a clue. The multiplicities are describing one direction, not both directions. So the other direction will have a question mark. There is something missing. So you write a question mark. Just to remind yourself that there is a question I have to ask my user. Clear, huh? This one is close to our environment, so we can understand it easily. Third one, again, it's in student and again, it's in academic environment, so it will be easy for you to understand. So please, let us not to waste time next lecture on these exercises, so that we can proceed moving to the other new topic. So please try them both. Okay. If you do, I gave you some other examples from the exams on the level of the exam. Any questions?
What does he mean by training modules?
Okay, let us change words. A software training program means a department. If you try to use an academic environment, this is training. But what's the corresponding in a university, for example? This is in a training institute, right? But let's assume here in the college. So a software training program, it looks like a department. Let's assume a department, IS, is divided into, or it has courses, right? Something like those are the modules to teach, to talk about this program. So if I'm teaching you programming, for example, so I can have programming 1, programming 2, Java and basic and so on. So these are modules that describe. If I'm teaching you software engineering, so this is system analysis, this is system design, this is database design, and so these are the modules if I'm teaching you the program of software engineering, and so on. Okay? Questions? Okay, let us stop here.